The comfort zone is a zone of environmental conditions that lie between 20 degrees Celsius and 25 degrees Celsius, and between 30% humidity and 60% humidity. As a mechanical engineer working in heating, ventilation and air conditioning, my job is really to make people comfortable. When you're designing a building in a new climatic zone that you're not familiar with, it's important to understand how hot and how cold it gets in order to bring the conditions within the building to within this comfort zone. On the Simmons Hall project at MIT, there was a clear desire to provide a building that could be comfortable without any use of mechanical cooling. We went a long way towards using passive measures, controlling the environment, and then the amount of mechanical cooling that we had to put in the end was really very minimal. On the Phoenix Federal Courthouse, the project had already started with other engineers, and they came up against a problem that they couldn't solve by themselves, which was how to cool this very large glass atrium in a desert environment without putting in very expensive equipment. We came up with an evaporative cooling solution, which was quite unusual in that that kind of cooling had not been used within a building to that scale beforehand. So I've learned a number of things from these projects. One of the most important is that I really need a major challenge to pull the best work out of me. I've also realized that the best outcomes invariably come out of a fundamental understanding of the principles of physics and engineering. This Lloyd's building is a project I worked on in the first 2 years of my career at Arup. Much of the work was fundamental physics, and that really launched me into the foundations of my career, which are based on a very deep understanding of fundamentals of building physics and the process of design. So the Lloyd's building really has a very important place in my career. It's really quite humbling to be recognized by one's peers as a fellow. There are very few of us in the firm. It's an accolade that I would place above any other that I've ever received. As an Arup Fellow, I think that there are 3 aspects to the role that I hope to deliver over the next few years. One is to keep our technical work and the quality of our design right at the highest level. The second aspect is developing young talent. Arup is best placed to actually develop the talent of the future. The third aspect is to create a strong external profile for the firm and to really make a difference in the world. The firm is all about shaping a better world, and I think each one of us has a duty to do that in our own way. We were asked to look at a project in a place called Arusha in northern Tanzania. And very surprisingly, all of the conditions in Arusha just clustered around this comfort zone. So it was as if this was the perfect climate. I didn't have to do anything as a mechanical engineer to really achieve comfortable conditions within the building. Just 100 miles away from Arusha is the Olduvai Gorge, where some of the earliest human remains have been found. So there's a continuous history of human occupation in and around that area in Africa that goes back several million years. So in a sense, we've actually evolved in that climate, and therefore wherever human beings have spread throughout the world, we still feel comfortable under those kinds of climatic conditions. So also, in a sense, my job as an HVAC engineer is to create a little piece of Arusha inside every building that I design wherever it happens to be around the world.